So today we are going to start with again a very simple problem. Okay, so I want all of you to solve it individually. Okay, let me know how you are first. You just take a note from me about the approach which you are going to use about it. And this approach and this problem statement, you have to understand it by yourself first. Okay, if you have any doubt, you can ask me, but you have to understand it by yourself what assumption you are making. You have to decide your own. So treat it like it will be a written test kind of a thing. Okay, think about it, how you can solve it. Okay, will that work? Drupad, Gopal, Jayant.
Yes.
Yes.
Okay, because why we are doing this exercise is because sometimes you went for the written test, okay, which is the first screening test, and once that is happen, you need to have uh, you don't have anybody to give you the answers or everything. You have to do go by your intuitions. You have to understand the problem by your own only. Okay, that is good. So just think about this. You have to solve this problem.
Nishanshu, there is a guarantee, right? That the size would be at least 2.
No, if you have, so nobody asked me this question that what if the input array will have the single element only like this. Uh, so in that case, your output should will have that single element.
All right.
I think everyone is done doing this. So let me give my thoughts about the solution what I might have think of, and you can check against my thought that whether we are aligned or whether you have something different. Okay, it's not necessary there is going to be a single solution only for the problems. There could be multiple solutions to the same complexity. So this is the array we are talking about. It is being said in the problem that you have to replace every element with the multiplication of previous and the next element. Okay. So first one and the last one is a special case because you don't have the previous and the next in this case. So you have to treat them as a separate case. So if I is equals to 0, you have to do a of 0 as a of 0 into a of 1. And similarly, if I is equals to n minus 1, last a of n minus 1 will be a of n minus 2 into a of n minus 1. This is. For the rest of the element, what I should have done is, since, for example, this 3, I have to replace this with multiplication of 2 and 4. But 2 is already updated. That I have to think of, that 2 is already updated. So I want 2 before it is getting updated. Okay. So we can use a extra temp variable which can store 2 for me before it gets updated, and this 2 I can use in the iteration for 3. Similarly, while calculating for 4, I should have updated the temp with 3 before replacing the 3 with 8. Okay, and this should go on for every other element. Okay, so this is the approach I should have been chosen to go with, and the complexity here is order of n, which I have seen. So, any doubts here? Anything you guys want to share with me? Rajan, Vijay, Pritam, Karamveer, Jayant. Okay. I have a certain questions with you for all you guys. Guys, how do you feel by solving this problem? Do you feel bored? Do you feel good? How you feel about solving this problem?
Good.
Astha, yeah, yes, Pritam.
I mean, yeah, it was good.
Okay. So the thing is, uh, in data structures, while we do the problem solving, when you completely solve a problem and you get a high confidence on your solution, it really help you to motivate. You feel happy about it. Okay. since it feels like you have achieved something, and that sense of achievement is kept you motivating in solving more and more problems. Once you lose that, so okay,
Let's take a
once
problem
you
directly
lose that excitement, then it will become very hard to crack in a DS. Try to keep the spirit up. I have one more question, one more problem for you guys.
without division.
That's a nice problem. I really like this one. I will put the link as well, so don't worry. Given an integer nums, okay, okay. Let's take the inputs as well. Okay, I will explain this problem to you guys. This problem says that you have to replace every element with the product of every other element except except itself. Okay. For example, if our input is like this, 1, 2, 2, 3, and 4. So 1 need to be replaced by 2 into 3 into 4. 2 need to be replaced by 1 into 3 into 4. 3 need to be replaced by 1 into 2 into 4. And 4 need to be replaced by 1 into 2 into 3. Means you have to replace every element by the product of every other element except the current element. Okay. And you are not allowed to use any division operator. Okay. Is the problem statement clear?
Yes, Nishant.
Okay. So this problem we have to solve. Give a thought about it. Again, give a thought about it, how you can solve it without using any division operator. And as a hint, think of the yesterday's class where we have used certain approaches to get it done. Okay. There might help you. Think about how we can solve this problem. Take your time. Okay. So guys, are you done with this? Aman, Asmita, Astha, Drupad, Jayant.
Yes, Nishant.
Yes.
So net code submission is also done. Cool. Let's see what my thoughts about this problem is. So what should I have done is I have maintained the two arrays. One is called as right, one is called as the left. Okay. Because if you see how we can think of this approach is, if you see here, which I have just explained to you, you will see that you to get the product of all the elements except this, we have multiply all the elements on the left side and we have multiply all the elements on the right side. This is the left and this is the right. So if we know the multiplication of all the elements till this element and all the multiplication from the right hand side till this element, then we can have our answer. Okay. So for example, for if I go here for 1, it will be 1 only. Okay, because there is no other element on the left hand side of 1, so it's better to keep 1. Then 2, it should be 1 again, this multiply by this. For 3, it should be 2. For 4, it should be 6. 1, 1, 2, 6. Similarly, from the right hand side, it should be 1 because there is no element on the right hand side of 4. So 4 into 1 is 4. 4 into 3 is 12. 12 into 2 is 24. Okay. So you can see that for any element, at that index, you have all the multiplication of all the elements on the left hand side and all the elements on the right hand side. This multiplication you have. Now, with this multiplication, what you can do? You can, for every index, you can do the LS into RS to get the answer. So once you do the LS into RS, you will get 1 into 24, this will be 24. 1 into 12, this will be 12. 2 into 4, this will be 8. 6 into 1, this will be 6. Okay, that's how you get the answer. Now, if you talk about the complexity, what is the complexity? Order of n. But if you talk about the space complexity, it is 2n. But this can be further reduced by just taking the single. This is an optimization I'm talking about here. So everybody listen carefully. So instead of taking 2 arrays, we can take one extra array to maintain the LS. And while calculating this, we can have the RS with us in a variable and we can work with the current element. So we don't actually need to maintain a RS as a separate array. Okay, so we can, with this approach, we can reduce the complexity from 2n to n. Okay, we just maintain a single temporary array. And for the right hand side calculation, we can just go on, or you can maintain the RS in a temporary variable. And when you proceed with the array to replace the element, you can at the time itself, you can calculate the LS. Is that clear? Guys, is this clear? Soumya, Sajan, Asta,
Nishant, I didn't understand. Can you please repeat it? Because if we are
the
storing
optimization
in,
part.
yeah,
Okay, so it will be like this. So suppose you have calculated the RS. We start from this part. LS we have not calculated yet. So how you will have proceed that int I equals to 0, I less than n, I plus plus. Okay. So what I will do, I will maintain a variable called ls. This is variable I initialize with 1. Okay. So what I will do and I will take an extra variable, let's say int temp. So what I will do, I will calculate to replace an element first, temp equals to a of I. I will take, then a of I will be equals to ls into rs. Okay. Then ls will be equals to ls into a of I. Okay. This is what I am going to use. Ls of, this should be ls of I. So if you look at the iteration here, this will be 0, 1, 2, and 3. So initially, if you go with the first iteration here, what you will get? Just debug this piece of code. You will have temp as a of I, which is 1. Then a of I means a of 0 will be replaced by ls. Ls is initialized with 1. Sorry. So 1 into rs will be 24. So you will be replacing 24. Now ls will become 1 into 1. Okay. So I am just writing above only. This is the one iteration. So after one iteration, ls will be 1 into 1. Okay, this is the first iteration. Now the second iteration we talk about. What happens?
I think here when you're saying ls equal to ls into ai, the ai value got updated, right? In the
Sorry, this should be 10.
10.
Yeah, thanks. So second iteration will be temp will be the current element. Now we are talking about a of 1, which is 2. The temp will be 2. A of I means a of 1 will be replaced by ls into rs of I. So ls will be getting as 1 into rs of I, which is 12. Now ls will be updated and it becomes ls into temp. So ls is 1, temp will be 2. So ls will be 2 for the next iteration. Okay. So third iteration. In the third iteration means we are working with a of 2, which is nothing but value is 3. So temp is 3. Okay. Then a of 2 will be ls. Ls is 2 now into current into rs of I. Rs of I will be 4. Okay. So this will be 8. And ls will be updated again. So ls will be 2 into current thing, which is 6. So LS, I made a mistake. No, LS will be 6. Okay, because this LS is going to be used in the next iteration. Okay, so is it clear how we are doing it now?
Yeah, it understood. Thank you.
Okay, so approach is remaining same, but the optimization you did it on your this part, on your coding part. Okay, where there you have done the optimization and report. Is it clear? Soumya, Sajan, Asta, Jayan, Gopal, Dupat.
Yes.
Yes.
Yeah, Nishant.
Yes, Nishant.
Cool. Let's move on to the next problem. Before moving to the next problem, let's take a break for 5 minutes. You guys can grab water, and we will be starting from 11:45. Will that be fine?
Yes.
Cool. This is one of the very famous, one of the very famous problem in array, and it is being asked a number of times by the companies. Okay. So if I can show you, it is being asked like in Facebook, it is being asked. Facebook, it is being asked 37 times. This is about last 6 months only. Amazon, it is being 37. Goldman Sachs, it is 33. Microsoft, it is 6. Google, it is 6. Apple, it is 5. A number of times. Okay, so you can understand about this problem, but this is not a very tough problem. I have a confidence all of you can solve this problem. Let's try to understand what the problem is in the first place, and then we'll see. Okay. So this problem is like, suppose you have given an array with the height of certain bars. Okay, so you have to tell how much water it is able to take. Okay, so if you draw this, if you draw the heights, so if you assume this is a bar graph and try to draw it, okay, so it will look like this. So let me put the numbers. We are working with this. Let's say we are working this. The second input 0. So 0 will be somewhere here. This is 0. This is 1. 0. Then we have a 2. So this is 2. Then we have a 1. So 1 is attached to 2. This is 1. Then we have a 0 again. Then we have a 1 again. And then we have a 3. So 3 will come here. Then we have a 2. So 2 will come here. Okay. Then going forward, this will be 1, this will be 3, this will be 2. Then we have a 1 again, this will be 1. Then we have a 2, so this will be 2. And then we have 1 again. And then we have a 1 again. Okay, this is. Now suppose a rain comes. Okay, when the rain comes, you can see there are certain spaces between this bar graph. Okay, so this is a bar graph. 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 So there are the certain spaces in between. So suppose rain comes, so the rain water can be filled in this gaps. Let's start from there. There will not be any water because there is no. So when you have to hold any water, you need both the sides to have the water. Okay. Water can be filled here. Similarly, if you look, water can be filled here. Okay. Water can be filled here. So we have to tell how much water cumulatively it can fill. So if you look at this point, so if we go one by one and look how much water it can hold. If you look at 0, it cannot hold any water because there is no left side to it to hold the water. 1 cannot hold the water because again there is no left side to help to capture the water. 0, it can hold the water because it can have something in its left and something in its right to hold the water. Okay. And how much water it can hold? Till the height of whatever the minimum is. Why the minimum is? Because otherwise it will overflow. Because if you look for this case, you have something in the left side and something in the right side to treat it as a container. Okay. And we will go for the minimum height because 2 in the left and 2 in the right and 1 in the left, because otherwise the water will overflow. Okay. So how much water it can hold till the height it is available 1 into and the width is 1. So it is 1 into. Similarly, if you look at 2, it cannot hold any water because the left side will not allow him to. Right side it can, but we need both the sides. 1 it can because in the left side we have a 2, in the right side we have a 3. So 1 can hold a water with the minimum of 2 into 1. 1 is actually so rectangular formula is length into breadth. So breadth is given as 1. So bar of width 1. So every bar is a width 1. Okay. So for 0, you have 2 in the left side, 3 in the right side. The minimum water it can hold is minimum of them into 1. Okay. One more thing about 1 is it can hold this much water, but there is still a height is present. Okay. So we know that that much water will not be placed. So we need to subtract that as well. Then 2 into 1, that is fine. Okay. 1, again the same thing, 2 into 1 minus 1. 3 cannot because there is nothing help to 3 on the left and the right side. For 2, again there is nothing to help on the right side. For this one, yes, it can hold certain water. This 2 cannot hold any water, this one cannot hold any water. Okay. So the cumulative water it can hold is 1 plus 1 plus 2 plus 1 plus 1. So it is like almost 6. So 6 unit of water it can hold. Okay. So given a positive array, you have given a positive array, you have this thing. You have the height of the bar represented, and if the water comes, you have to tell the total cumulative water it can hold. Okay. Is it clear what is asked in the problem statement? Aman, Asmita, Asta, Drupad.
Yes.
Think how you can solve this problem. Okay. Think how you can solve this problem. Understand the problem, and any doubts, ask me in the chat. Okay. So, any thoughts, anyone here, how we can solve this? Before I pitch in, let's we round up. Aman, do you have any thoughts here, how we can solve this?
Yes, Nishant. So I was thinking of kind of previous problem, like creating two array, which will give me the right and left values of max.
Okay, so sorry to
So
interrupt
something,
here. Certainly.
yeah.
Why you thought of doing that?
So while he was like discussing this, like when you're creating the diagram, I just got this idea that if I have the left and like suppose you are at the bar 0, right? If you have the left and right max, and you know whatever the max value, right, you can just uh, what you can do at the current var, if you have the right max and if you have the left max, you can just subtract them, and it will give you the difference of those two, which can be accumulated here. And then if that particular var is having some height, then you can just subtract that as well.
Okay. Okay, that's nice. Okay, go on. Then you have two arrays, left side and the right side. Then
Yeah. But I am stuck. What will happen for the initial and the last value? How we have to handle those? Like for 0, like at the index 0, it should be
Okay, let's see.
starting with 0, since there is no right max or left.
Let me ask Jayant. What do you think about the solution of this problem?
Yeah, thanks, Nishant. So what I'm thinking is to store kind of ranges, like we see some pattern here, right? Where we start from a boundary. In case we start with any other number apart from 0, from left to right, and we go to an extent where we see that the height is growing, and then at some point of time I see it is now decreasing. So I just consider from the beginning index to an index where I mean until I'm growing, right? So I consider that as one range, right? So I will have an array where I store the ranges, and then what I do is I iterate the input array, and I check whether the current index fit into the range or not. And if it fits into the range, I just try to subtract it from the range. And if it is a negative value, I don't consider it. If it is a positive value, I add it to a cumulative sum, which would be the output at the end.
Okay. Pratham, how will you solve this?
Similar way, the thing is, we just so every time water is collected, we just need to know if there is a bigger block building present on my right hand side and my left hand side, because only then the water will be collected. So after getting the, after getting the two heights for a particular what is it called, for a particular building, after getting the what is that called, after getting the container endpoints, as in the left endpoint and the right endpoint, I get to know that the water that the water will be collected over there, and then for each height I'll be subtracting. I'll be I'll be subtracting the current height of my current building minus the whatever the difference I get from the left endpoint and the right endpoint.
Okay. Soumya?
Hi Nishant. I think first we need to ignore the 0th index and the last index, because there is no boundary in the first and the last. And then I will go with the maximum approach. Max of left and max of right, and then we need to subtract the same way.
Okay. Okay. So let me summarize the solution for all of you. Okay. So everything from the motivation and everything. So what happens here is, if you go back to the description when I was telling you, explaining the problem to you, I have mentioned clearly that water can be contained only on a bar when you have something on the left side and the right side. Okay. And that too when it is bigger than that. So for example, this one, it can contain water only if you have something bigger than one on the left side and bigger than one on the right hand side. Okay. Guys, give me a minute, I'll move back. Yeah. So what we are looking at is, we want the bigger number than this current number on the left side and the right side. So one of the brute force approaches, so I'm talking about the brute force approach, where for every element you go in the left side to get the maximum element then 1, and you go in the right side to get the maximum element then 1. And we are okay, so whatever the maximum element on the right hand side, whatever the maximum element on the right hand side, we will go in. For every element we will keep on finding. Okay, but that will be order of n square, because you have to go for every element on the right hand side and the left hand side. Okay, so that is something which is we are not seeking for. So Going back to the explanation of the yesterday's problem, where instead of calculating the max every time, we are trying to utilize the known information. Okay, so here we will do the same thing. So in the second approach, what we can do, we can use two separate arrays for the same thing. Okay, so let me write down this array here. We have 0.
And Nishan, sorry for interrupting, but in the brute force approach, when we are finding the max in the left and right, that doesn't work, right?
No, that will work now, because once you know the maximum element, for example, 2 is, for 1 it is 2, for 1 in the right hand it is 3. So what we will do, we will take the minimum of left max and right max. We will take that because water can contain till the minimum of them minus A of I. A of I representing the height. So
Okay.
that we will do. So this will be like, if you do this for all the bars, you will have the total cumulative.
Okay, let's say in this case, in the second index where there is a first 0, right? So the maximum on the left side is 1 and the maximum on the right is 3, right?
For this 0?
Yes. So the maximum on the left,
so
the max on the right is 3.
So we need the immediate bigger element.
Okay, yeah, that's what. Yeah, now it makes sense.
Let me write it down. Immediate bigger element. Immediate max. Immediate max on left and right. It makes sense now?
Yes.
0 1 0 2 1 0 1 3 2 1 2 1. This is the array we have. If I write the indexes here, 0 1 2 3 4 5 6 7 8 9 10 and 11. Okay. So how you will build the max is left max is left is right. Okay. I will do the same. Review this one. Yeah. We will have the same array here. Okay. We will do this and then yeah. So initially, now what I'm doing is I am including, for my calculation, I am including the current element also while calculating the left side and the right side. This one, this one, this one, this one, this one, this one, and this one. Well, so let's start and filling up with this. So if I look at this, so I'm including the current element also, so we don't have any left side, so I will be keeping this 0. Now among 0 and 1, which is bigger? 1 is bigger. For 0 and 1, which is bigger? 1 is bigger. So this element represented what is the max you are getting. So 2 and 1, which is bigger? 2 is bigger. 2 and 1, which is bigger? 2 is bigger. 2 and 0, which is bigger? 2 is bigger. So this 2 represents that what is the immediate maximum element for this 0. 2 and 1, which is bigger? 2 is bigger. 2 and 3, which is bigger? 3 is bigger. 3 and 2, I will write here, including current element. Okay. 3 and 2, which is bigger? 3 is bigger. 3 and 1, which is bigger? 3 is bigger. 3 2, 3 is bigger. 3 1, 3 is bigger. Now we will filling it from the right hand side. So for 1, it will be 1 only. For 2 and 1, 2 is bigger. 1 and 2, 2 is bigger. 2 and 2, 2 is bigger. 2 and 3, 3 is bigger. Okay. Then for 1 and 3, 3 is bigger. 0 and 3, 3 is bigger. 1 and 3, 3 is bigger. 2 and 3, 3 is bigger. 0 and 3, 3 is bigger. 1 and 3, 3 is bigger. 0 and 3, 3 is bigger. Like that. Okay. Just a minute, guys. Give me a minute. For 0 then. Okay. One statement I want to make it correct actually. Here it should not be the maximum immediate max. I have to make it correct. It should not be immediate max. It is the maximum on the left and the right hand side. Why it should be? I will tell you the reason. So it should not be the immediate one. Why? Because let's suppose it could be like this also. Suppose this is. Okay. And you are seeing till here only, but it is not the case that 2 is obstructing this. If this is bigger, let's suppose this is not 1, this is something bigger. Let's say this is 5. So how the water will be held here? It will be held till the height of this 3. Okay, 3 is not immediate right. It's the overall the maximum element for this. So it is not about the immediate left or immediate right. It's about the what is the maximum element you have gotten in the left side and what is the maximum element you have gotten in the right hand side. Okay, so this correction I want to make that it is not about the maximum element which you are getting in the left and right. Am I correct? Am I making sense?
Yes.
Why it is not immediate left and immediate right? Okay, so here now we can do the calculation. So whoever is the minimum is we will take that. So 0 is minimum, 1 is minimum, 1 is minimum, 2 is minimum, 2 is minimum, 2, 2, 3, 2, 2, 2, and 1. Now what I will do? I will subtract the current element in this. So 0 minus 0 we will be getting. I'm writing down here after subtracting the current value. 0 will be 0. 1 minus 1 is 0. 0 minus 1 minus 0 is 1. 2 minus 2 is 0. 2 minus 1 is 1. 2 minus 0 is 2. 2 minus 1 is 1. 3 minus 3 is 0. 2 minus 2 is 0. 2 minus 1 is 1. 2 minus 2 is 0. 1 minus 1 is 0. So eventually, if you submit all this up, you will get the 6 answers. Okay. So in this, we are seeing the time complexity is order of n, but the space complexity we are seeing is 2. Okay. Is it clear with what I just explained? How we can make the use of the left side and the right side?
Nishant, can you explain the last step where you did the subtraction from the original array? After subtracting, yeah.
It's the same thing. See, you have for every index, you have find the minimum of the left side and the right side. So whatever the minimum of this is 0. And I subtract the current element value because that much height you have to subtract it now. So that's what I did. Okay. So 0 and 3 minimum is 0 and I subtract 0 out of it. 1 and 3, so minimum is 1, I subtract 1 out of it. 3 and 1, 1 is minimum, I subtract the current element which is 0, height of it. Like that. So the formula which we have used is this one.
Nishant, one question. Which is better, the time complexity should be max or the space complexity? Like how to decide first is better or the second
Time
approach
complexity is the one which we want to reduce as much as possible.
Okay, so we never care about the space one. Not
No,
much.
we care about this space because if you see, this 2n can be reduced further to n by the optimization we discussed in the last problem. If you remember in the last problem, we
Right.
discussed that we can calculate the right side and for the left side, we can calculate on the go. So we bother about, but the priority we give it to the time complexity rather than the space complexity. Okay. So what I want from you guys is to apply the same thing on this one and tell me what the answer you will be getting in the chat. Apply the same thing, same logic, everything will be on this and tell me what the answer you will be getting. So people who are, okay, so 10 will be the answer. Can you guys code this? Complete this? Aman, Smita, Astha, Gopal, Pritam, Samya, Sujan, Vijay. Can you guys quickly code this? Guys, am I audible?
Yes.
Okay. Please code this. I have given in the link in the lit code. Please complete this. So as soon as you complete, we can wind up the session. This was the last problem.
Nishant had a doubt about the space complexity.
Yeah, tell me.
Can we have space complexity as in quadratic or cubic? Like it's currently 2n and everything, right?
Generally, I have not seen, but it can be possible. Generally, I have not seen. Because generally you take the extra space equal to the input size or something. Okay. So I have not seen that, but it is not like that. It is not possible, but I don't have any example right now. I will figure out a thing. Okay. And guys, please code this once your lit code submission is done. Okay. Then you can take the day off, or means you can leave the meeting. It's up to you. Okay. Better not to. I will show you my implementation as well. So please try to do it in the lit code.
Nishant, just a question here. Is it possible that we store both the left and right boundaries in single array, but maybe like a tuple?
You can do that, but you didn't get any advantage, no?
Yeah, probably
When you
code complexity would be simpler, but in terms of time and space complexity, it would be same.
time is going to be the same. Space complexity is like when you're using tuple, you're storing 2n elements only, no?
Yeah.
So it's going to be the same as using the two arrays.
Yes.
So the space optimization, the last problem which we discussed, the same way the space optimization can be done here. Okay, so guys, are you guys done putting this?
Yes, Nishant.
Okay, so I'm putting my solution here. It is not the optimized one. The optimized one you can code it by yourself. Okay, if you are not done, you can do it after the class as well. Cool. So I'm stopping up here today.